Ever woken up at like 2 a.m. in a cheap hotel room with, terrible reception to a phone call that changes your life?
That's a pretty specific scenario.
Well, that's exactly how one of our Nobel Prize winners found out he'd won the biggest prize in physics.
Wow.
And get this, for his work on artificial intelligence.
Okay, now that's a story I want to hear.
Hello?
Oh, hello. Is this John Hopfield?
This is John Hopfield speaking, yes.
Oh, hello. My name is Adam Smith. I'm calling from the website of the Nobel Prize, and Mary very kindly set up this time to talk to you. Is that okay?
Yeah.
You and the rest of the world, we're diving into the work of Geoffrey Hinton and John Hopfield, the masterminds, who showed us that AI isn't just science fiction, it's award-winning physics.
Yeah.
You sent over a fascinating collection of materials.
Absolutely.
Including the actual Nobel Prize announcement, a transcript of a call with Hinton right after he won, and this article that does an amazing job at breaking it all down in plain English.
Absolutely. And by the time we're done, you'll not only know why this work is worthy of a Nobel Prize, but also get a sense of the incredible future it points to, one that even has Hinton a bit worried.
Yeah, we'll get to that part. But first, back to that phone call. Can you imagine 2:00 a.m., probably squinting at a flickering motel room light, and suddenly you're talking to the Nobel Committee?
Oh my goodness.
I'd assume it was a prank too.
Hinton himself said his first thought was disbelief in the transcript you shared.
Yeah.
He mentions thinking, is this a prank call?
I mean, who could blame him? But it just goes to show this wasn't just any award. And what's even more fascinating, it's about a concept that feels incredibly futuristic. Artificial neural network. So before we get to the why it matters part, those of us who don't have PhDs in computer science, what exactly are artificial neural networks?
Imagine trying to teach a computer to recognize a cat.
Right.
Traditionally, you'd have to program in all sorts of rules. Pointy ears, whiskers, a tail. But artificial neural networks are different.
Okay.
They're inspired by how our brains work. Instead of rigid rule, they learn from seeing lots of examples, just like how a child learns to identify a cat without someone explaining every detail.
So instead of programming, it's more like training.
Exactly. And it's this ability to learn from data that makes them so powerful. Now, one of our Nobel laureates, John Hopfield, created something called the Hopfield network. Picture trying to remember a word, and your brain sifts through similar sounding or related words until you land on the right one. That's essentially what a Hopfield network can do with images.
Okay.
It can even fix errors, like a supercharged autocorrect for pictures.
So basically, it's like having a super-powered version of the feature that saves me from my terrible typing every day.
Right.
Thank you, John Hopfield.
Precisely. But then Hinton comes along and takes this idea of networks to a whole new level with something called the Boltzman Machine, which, and here's where the physics comes in, draws on concepts from 19th century thermodynamics.
Okay, you're speaking my language. Thermodynamics, like the study of heat and energy and all that, what does that have to do with AI?
What's fascinating is that Hinton realized he could apply these physics concepts to create a network that could learn on its own without being explicitly programmed. Imagine a child learning to tell the difference between cats and dogs without anyone ever explaining the rules to them.
Yeah.
That's kind of what a Boltzmann machine can do with data patterns.
Wow.
It can identify and categorize them based on their inherent characteristics.
Wait, so we're saying these networks can basically teach themselves?
Right.
Before we get too far down that rabbit hole, you mentioned that Hinton used actual physics concepts for this Boltzmann machine.
Yes.
Can you unpack that a bit more for us?
Absolutely. So imagine a rugged landscape with, mountains and valleys.
Okay.
In physics, we use this kind of landscape to represent energy state, where valleys are low energy and stable, and mountains are high energy and unstable.
Okay.
Now picture data points. As if they are trying to find their most stable, lowest energy state on this landscape.
Okay, I'm kind of with you. The data is like rolling down hills.
That's a great way to think about it.
Okay.
Hinton's breakthrough was realizing he could use this energy landscape model, borrowed from physics,
right,
to allow the Boltzmann machine to learn from data. The network adjusts its internal settings, finding the smoothest path for those data points to settle into the lowest points on that landscape.
Okay.
And here's the kicker. It does this without anyone telling it what the right answer is.
So it's not just mimicking human learning. It's almost like it's tapping into some fundamental rule of the universe about how systems naturally seek stability.
Right.
No wonder people are calling this Nobel-worthy stuff.
Exactly. And here's where things get really mind-boggling.
Okay.
Remember how we talked about those nodes in these networks?
Yeah.
Think of them like tiny processing units.
Okay.
Kind of like simplified versions of the neurons in your brain.
You mentioned nodes earlier for those of us who aren't AI experts.
Sure.
What exactly are those?
Think of them like tiny processing units.
Okay.
Kind of like simplified versions of the neurons in your brain.
Okay.
So Hopfield's early networks had a few dozen of these nodes. Today's AI models have over 1 trillion.
1 trillion.
Yeah.
Hold on, let me get that number straight. That's like going from the population of a small town to the entire planet in terms of processing power.
Exactly.
Wow.
That gives you a sense of just how rapidly this technology is advancing. And that brings us to the other side of the coin.
Okay.
Hinton's concern about where all this is headed.
Yeah, it seems like even he,
Right.
the guy who helped create this incredible technology, is a little uneasy about its power.
Right.
But before we dive into the existential threat part of the conversation, I'm still reeling from this whole idea that the tools Hinton and Hopfield developed for AI are now being used to solve problems in physics.
Yeah.
It's like physics gave birth to AI,
Right
which
on.
then looped back and handed physics a toolbox upgrade.
It's a remarkable full circle moment.
Right.
And we're already seeing the impact, especially in fields like particle physics.
Okay, now you're talking about my favorite topic, smashing atoms together at nearly the speed of light. But seriously, how does AI actually help physicists make sense of something as complex as the universe?
Imagine you're trying to put together a massive jigsaw puzzle, but instead of a few hundred pieces, you have billions, and they're all almost identical.
Right.
That's essentially the challenge physicists face when analyzing data from particle accelerator, like the Large Hadron Collider.
Oh, okay. Yeah, that's way more than any human could handle.
Exactly. But these systems are incredibly adept at recognizing even the subtlest pattern. In massive data sets,
Right.
they can sift through billions of data points and identify the signatures of new particles,
Wow.
new forces, things that might have taken humans decades to uncover.
That's a game changer for our understanding of the universe. It's like having a super-powered magnifying glass
Right.
to study the fabric of reality. But back to Hinton's concerns. He's compared the potential threat of AI. Why is he so worried?
Right.
And what does he think we should be doing?
Well, imagine for a moment, instead of a warming planet, we have a technology so powerful, so capable of learning and evolving on its own that we can't fully predict or control its long-term consequences.
It's like handing a toddler the keys to a rocket ship. They might figure out how to make it go fast, but who knows where they'll end up
Exactly.
or if they'll even know how to land safely.
That's a good analogy.
Yeah.
With climate change, as challenging as it is, at least we understand the problem
Right.
and solution, even if implementing them is a different story.
Right.
Hinton's point is that with AI, we're still grappling with the instruction manual, so to speak. We're creating something potentially more complex than we can fully comprehend.
Okay. I see why he's concerned,
Yeah.
especially given how quickly things are moving. But are we talking about a Hollywood-style robot apocalypse here?
Wow.
Or are there other, maybe less dramatic concerns?
Well, the good news is we're not at the robot uprising stage just yet.
Okay.
But Hinton's worries, and those of many others in the field, are about the unintended consequences of such a powerful tool. For example, what happens when AI becomes so good at certain jobs that it disrupts entire industries?
Right. The economic impact of AI is a big one. Job displacement,
Yeah.
the need for new skills, even the potential for widening inequality. If the benefits of AI aren't distributed fairly.
Precisely. And those are just the economic implications.
It's almost like this technology is forcing us
Right?
to confront some really fundamental questions about ourselves and our place in the universe. So what do we do? How do we navigate this?
Right.
Because throwing the brakes on AI development altogether doesn't seem like a realistic even desirable solution.
I agree.
Right.
I think the first step is awareness. Exactly what we're doing right now.
Right.
Having open, honest conversation about both the immense potential and the very real risks of AI. We need to move beyond the hype and fear and start grappling with the nuanced realities of this technology.
It sounds like we need a delicate balance between fostering innovation and safeguarding humanity. How do we even begin to strike that balance? Are we talking about regulations? Global agreements?
Those are all part of the conversation, and there are no easy answers. Some argue for strict regulations to prevent AI from being used for harm, while others worry that too much control will stifle progress.
It's like we're trying to write the rules for a game that's constantly changing right in front of our eyes.
That's a great way to put it.
Right.
And it's not just about laws and regulations. It's about fostering a sense of responsibility, of ethical development. Among those who are building and deploying these technologies, we need AI that's aligned with our values, that enhances our lives, rather than diminishes them.
So to bring it back to where we started with Hinton and that Nobel Prize winning work, it sounds like his biggest contribution might not just be the technology itself, but the questions it raises.
Absolutely. Hinton's work has ignited a global conversation about the future we're creating, one where intelligence isn't limited to biological beings. And that conversation, as complex and challenging as it may be, is perhaps the most important one we can have right now.
That's a powerful thought to end on.
Yeah.
If these artificial neural networks are indeed a reflection of our own intelligence, then the future of AI might depend less on algorithms and more on the choices we make today, the values we prioritize, and the kind of world we want to create, not just for ourselves, but for the generations that follow. Thanks for taking this deep dive with us.
My pleasure.
We'll leave you to ponder that.